Assalamualaikum and welcome to our group presentation. My name is Muhammad Kmayu Bezgan Nain from the class DTP2A. My matrix number is 09DTP21F1049. Today, our group will talk about integrals. So, what are integrals? Integral is a function which a given function is the derivative. Integration is basically used to find areas of two-dimensional region and computing the volumes of three-dimensional objects. Therefore, finding the integral of a function with respect to x means finding the area to the x-axis from the curve. The integral is also called antiderivative as it is the reverse process of differentiation. Basically, there are two types of integral. The first one is definite integral and the second one is indefinite integral. Definite integral is defined as the integral which contain definite limits, which is upper limits and lower limits. It is also named as Riemann integral. It is represented as the following. Meanwhile, indefinite integral is defined as the integral whose upper and lower limits are not defined, which is fx dx equal fx plus c is defined as indefinite integral where c is the constant value. That's all from me, and I will pass it to my associates.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Abdullah Halim from DTP2A. My method number is 09DTP21F1042. I will be the one who present about how to find area under the curve. First of all, the area under the curve can be calculated through three simple steps. First, we need to know the equation of the curve. Y equals to function, the limits across which the area is to be calculated, and the axis enclosed in the area. Secondly, we have to find the integration and antiderivative of the curve. Finally, we need to apply the upper limit and lower limit to the integral answer and take the difference to obtain the area under the curve. The area of the curve can be calculated with respect to the different axes. As the boundary for the given curve, the area under the curve can be calculated with respect to the x-axis or y-axis. For special cases, the curve is below the axis and partly below the axis. For all these cases, we have the derivative formula to find the area under the curve. And the area with respect to the x-axis is like here. Here we shall first look at the area enclosed by the curve y equals to function x and the x-axis. The below figure present the area enclosed by the curve and the x-axis. The bounding values for the curve with respect to the x-axis are a and b, respectively. The formula to find the area under the curve with respect to the x-axis is a equals to limit ab function dx. I have inserted the graph inside the slide. To end my turn, I will pass the next slide to the next presenter. Thank you.
Assalamualaikum. Okay, hello. How to find area under the curve? Area with respect to the y-axis, the area of the curve bounded by the curve x equal fy. The y-axis across the lines y equals a and y equals b is given by the following below expression. Further, the area between the curve and the y-axis can be understood from area of the curve with respect to y-axis. And the next slide, how to find area under the curve. Area below the axis, the area of the curve below the axis is a negative value, and hence the modulus of the area is taken. The area of the curve y equal fx below the x-axis and bounded by the x-axis is obtained by taking the limits a and b. Then the formula for the area above the curve and the x-axis is as follow. And this formula. Okay. Then the next slide, how to find area under the curve. Area above and below the axis, the area of the curve which is partly below the axis and partly above the axis is divided into two areas and separately calculate. The area under the axis the area under the axis is negative, and hence a modulo of the area is taken. Therefore, the overall area is equal to the sum of the two areas. A equal A1 plus A2, then A equals A1 plus A2. Okay, this is a formula. Okay, you can see. Okay, thank you. That's all for me. Okay.
Assalamualaikum, my name is Muhammad Fikri Hakim bin Mazlan. My matric number is 09DTP21F1064, and today I will be the next presenter on how does integral affect your everyday life. We took an example in agriculture on integral. Agriculture is the art and science of cultivating the soil, growing crop, and raising livestock. It includes the preparation of plant and animal products for people to use and their distribution to market. Agriculture provides most of the world's food and fabric. Cotton, wool, and leather are all agriculture products. Agriculture also provides wood for construction and paper products. These products, as well as the agriculture method used, may vary from one part of the world to another. This is one of the examples in integral problem in agriculture and solution. As you can see in the diagram below, calculate the area under the curve of function f(x) equal 7 minus x times 2. The limit is given as x equal minus 1 to 2. The area under a curve between 2 points is found out by doing a definite integral between the 2 points. To find the area under the curve y equal fx between x equal a and x equal to b, integrate y equal fx between the limit of a and b. This area can be calculated using integration with given limit. So, the conclusion is, to summarize what we have presented earlier, integration learning encourages active participation in relevant real-life experience. It can be used in agriculture and others, as function and the equation for their area between its graph and the x-axis are related to each other by antiderivative.